Hi students, I am Prashant B. Chandran, Assistant Professor, Automobile Engineering Department, SN80, Adur. Today, I am in front of you with a video in order to teach you about the second part of our fifth module, that is welding. The portions I am going to take in this video is Introduction to Welding, Classification of Welding, Definition of Welding, Welding Process, Welding Positions, Types of Welds, Weldability, and Solidification of weld metal. Okay. First, introduction. Welding is one of the fabrication process which is widely used to join two or more metallic components to make a single part. Okay. The products obtained from the manufacturing process like casting, rolling, extrusion, etc. cannot be directly used as products for the final usage because of some reasons. They may be machined or joined together by using some fabrication processes or fastening units. The metal joining processes are among the secondary manufacturing process. Okay. These can be classified based on various criteria into the following categories. First one, mechanical fastening using bolts, nuts, rivets, etc. Second one is adhesive bonding using glues, resins, gums, etc. Third one is welding, then soldering and brazing. Okay. The first two, that is mechanical fastening and adhesive bonding, etc., are not permanent joining methods. Okay. They are just temporary joining methods. But welding is a permanent joining method where the joint is obtained by the metallurgical fusion process. Okay. Here the interface of the two components to be joined is heated to a temperature near or above the melting point and a joint is made. During this process, pressure may be applied in certain cases and filler materials may or may not be used. Our next topic is classification of welding. Welding can be classified on the following basis. First basis, arc welding. Arc welding can again be classified as shielded metal arc welding, submerged arc welding, gas tungsten arc welding, gas metal arc welding, plasma arc welding, carbon arc welding. The second category is resistance welding. It is again classified as spot welding, seam welding, projection welding, percussion welding, and flash welding. Third one is gas welding. That is, it can be classified as oxyacetylene gas welding, air acetylene gas welding, oxyhydrogen gas welding. Okay. Third category is solid state welding. Solid state welding can be classified as ultrasonic welding, friction welding, diffusion welding, explosion welding, and forge welding. Other welding processes include electron beam welding, electro slag welding, laser beam welding, thermic welding, and induction welding. Okay, these are the various classifications of welding. Next, definition of welding. Welding can be defined as a localized coalescence of metals wherein coalescence is obtained by heating to suitable temperature with or without the application of pressure and with or without the use of filler materials. Welding produces a solid connection between two pieces called a weld joint. Okay. The product obtained by the process of welding is called as weldment. Base metal means the pieces of metal which are being welded to form a weld joint. That is, welding is the process of joining two pieces of metal by fusing to produce a single piece of metal. The two pieces of metals are joined together by the application of intense heat or pressure or both to melt the edge of metal so that they fuse to form a permanent joint. That is the peculiarity of welding process. Next one, welding positions. Okay. There is various welding positions are there. They are flat, vertical welding, horizontal welding, or welding, etc. These are the various positions of welding. Next, type of weld. Common type of welds used are fillet weld and groove weld. Okay. In corner, lap and T joints, fillet weld is used. That is, fillet welds are mostly used in corner, lap and T joints. Okay. Here, a minimum edge preparation is needed, and the filler metal is used to create a cross section approximately of a right angle triangle. Okay. In case of groove welds, edge of parts need to be prepared to the shape of a groove, just a groove-like structure. In butt joints, shapes like square, bevel, V, U, and J-shaped grooves are prepared with single or double sides as shown in the diagram below. You can see it clearly in the diagram. Okay. Next, weldability. The capacity of a metal to be welded into a suitable design structure and to perform satisfactorily in the intended service. The capacity of the metal is called as weldability of the metal. The quality of a weld and the ease with which the welding is carried out determines the weldability. Various factors that affects weldability are welding process, second one properties of base metal, third one properties of filler metal, fourth one surface conditions. Okay, these are the various factors which affect weldability. Our next topic is solidification of weld metal. Okay, that is, if a welding process is to be done, in a typical weld joint obtained from a fusion welding process, there are three distinct zones which can be identified easily. Okay, these zones are base metal, heat affected zone, and weld metal. Okay, can be easily seen in this diagram, first diagram. When a filler material is used, then the central zone consists of a mixture of base metal and the filler metal. Okay, if a filler material is used, then the central portion consists of both base metal and the filler metal. This portion is called the weld metal. Okay, when filler metal is not used, the central zone is composed of resolidified base metal. That is, whenever the filler material is not used, then the central zone consists of only the base metal, which is in a resolidified form. During the welding process, the intense heat will melt the base metal and filler metal if present in the fusion zone. That is, when welding is done, very huge amount of heat is there and which melts the base metal. If filler is available, it also melts the filler metal in the fusion zone. This molten metal is later allowed to cool down to the room temperature and solidify. That is, this molten metal is allowed to cool to the room temperature and solidify in a slow manner. The solidification process is similar to casting and columnar grains are formed. Okay, this solidification process is just similar to casting process, and some columnar grains are formed. Okay, these grains are shown in the second diagram. These columnar grains grow parallel and opposite to the direction of heat flow. These grains grow parallel and opposite to the direction of heat flow. That is, in general, the weld metal has a cast structure having coarse grains since the cooling occurs very slowly. Okay, ഈ കൂളിംഗ് വളരെ ചെറുതായതുകൊണ്ട് ഇതിനൊരു കാസ്റ്റ് സ്ട്രക്ചറും കോഴ്സ് ഗ്രെയിൻസുമാണ് അതിനകത്ത് കാണുന്നത്. ഡ്യൂ ടു ദിസ് ദ വെൽഡ് മെറ്റൽ ഹാസ് ലോ സ്ട്രെങ്ത്, ടഫ്നെസ് ആൻഡ് ഡക്റ്റിലിറ്റി. ഈ കാരണം കൊണ്ട് തന്നെയാണ് ഈ വെൽഡ് മെറ്റലിൻ്റെ സ്ട്രെങ്ത് കുറവായിരിക്കും, ടഫ്നെസ്സും ഡക്റ്റിലിറ്റിയും ഇങ്ങനെയുള്ള പ്രോപ്പർട്ടീസ് എല്ലാം കുറവായിരിക്കും. ദീസ് പ്രോപ്പർട്ടീസ് ക്യാൻ ബി മോഡിഫൈഡ് പ്രോപ്പർലി ബൈ സെലക്ടിങ് എ പ്രോപ്പർ കോമ്പോസിഷൻ ഫോർ ഫില്ലർ മെറ്റൽ ഓർ ബൈ ദ പ്രോപ്പർ ഹീറ്റ് ട്രീറ്റ്മെൻറ്റ്സ്. അതായത് ഈ പറഞ്ഞ പ്രശ്നങ്ങൾ അവോയ്ഡ് ചെയ്യാൻ വേണ്ടി നമുക്ക് ഒരു പ്രോപ്പറായിട്ടുള്ളൊരു ഫില്ലർ മെറ്റൽ ഇതിനകത്ത് വെൽഡിങ്ങിൽ യൂസ് ചെയ്യാം, അല്ലെങ്കിൽ നമുക്ക് ഹീറ്റ് ട്രീറ്റ്മെൻറ്റ്സ് യൂസ് ചെയ്ത് ഈ പ്രശ്നങ്ങൾ, അതായത് ഈ ഡിഫക്ട്സിനെ നമുക്ക് അവോയ്ഡ് ചെയ്യാൻ പറ്റുന്നതാണ്.